Good morning. Welcome to this short series. Today's topic is 7QC tools. So we will be covering the basic tools, why it is important in industry. When you face a quality problem, first thing is you start using something called basic tools in quality. So 7QC tools is basically uh, first level of QC, quality tools. First level means getting into high level process improvements, high level process optimization actually starts from the simple data collection. So in the various forms, you collect the data and probably that once we start collecting the data, once we start visualizing the data in various forms, that itself solves 50% of the problem. Majority times, many companies, especially small and medium enterprises, they don't have a basic 7 QC tools in place in manufacturing setup. So they try to do ad hoc way many things. So this a short series, basically we are trying to tell those tools, techniques, how to actually, what are those tools we are going to discuss, and then how quickly we can use, and what type of analysis we can make from that. So if you see the list of 7 QC tools, basically these are the tools. We flow charts, a basic first one is flow chart. Any process improvements, anything in a production line or manufacturing line or service line, it starts with the process flow. You need to capture the process flow, how the product or service moving, basically, like when you assemble a product or when you manufacture a product, how actually that moving in the production system. Same thing in the service industry. So you need to know the uh, macro view of entire process, so that flow charts helps you to understand quickly the entire process. So check sheets is a second important tool in QC 7 QC tools. We'll see how we actually can build that check sheets. It's a one form of data collection about the defects, about the quality in the production line. Histogram, basically extracting the data and showcasing that in a histogram format, because now Excel is everybody started using Excel. So you can, once you collect the data, you can build histograms. So Pareto chart is summarizing the basically the thing, like how actually you focus more on a few causes. So Pareto chart is basically 80-20 principle used to basically to identify those which causes 80% of the problem. There may be a 20% of the causes causing 80% of the problem. That we will see how to actually build those thing in using Excel. A scatter diagram is just building so like just plotting the data on a XY axis, and seeing that how actually is the you try to see how that spread. So this will give you something like mm, about the process quality. So same thing, control charts. Control charts, so only difference between scatter diagrams and control charts. Control charts comes with the, you calculate upper boundary, lower boundary, and then plot the things about the process parameters, and that's a thing actually. That's basically the difference between scatter diagram and control charts, having a medium middle line, and upper limit, upper control limit, lower control limit, and then you start plotting the points using the data from your process. Cause and effect diagram. It is like we also call fishbone diagram, root cause diagram, and cause and effect diagram. So this is very, very easy way to basically communicate about the root cause, effect and cause. So you can easily communicate to the group of people when you try to solve the problem. You try to use this. So basically, is very easy to document, very easy to communicate. And run charts. Run charts is a more of like thing. You just capture the data over a period of time continuously. Time series type. It is continuously taken over a suppose 1 week time. Every day you capture the data about the process quality parameter. So you just plot that, and that becomes your run chart. So come back to the check sheets. Check sheets is like this. If you are in a service center, you are counting billing errors. Basically, like you group them, identify those, and on a specific day, how many types of errors committed. You just count that. So it is like a simple way of showcasing, capturing the thing. At the same time, this will also helps you to like quickly visual way of representing the defects in the production in a service delivery. Like you quickly understand what is uh, the the defects, number of defects happening, which one is like easily you can see, which is a more like which error is occurring more frequently, which error is occurring less. You can see visual thing on a sheet. So in a product also, when you capture the product related defects, you can design appropriate check sheet, very innovative check sheets. If you design, it is very easy. It is a visualization of entire thing, where which location with the product defect is happening, you can easily capture. So same thing, it's Pareto chart is the one already I said. 80-20 is the one thing. 80% of the problems may be attributed to the 20% of the causes. So this when you get information about the defects, so you put them in a some on the basis of number of defects, you arrange them in a descending order and calculate the percentage, each contribution, each defect contribution, and then calculate the cumulative contribution to the total defects, percentage of cumulative percentage error you calculate, and then you map that you the simple bar chart to basically to plot that. And you by seeing this, which one is actually more frequently happening. So these two contributing 80% of the defects. We see all these defects, out of these two are basically concentrating. So it will helps you to focus on major issue, major problem. And control charts, I said this once you know the process parameters, you can calculate upper control limit, lower control limit, and then average mean you calculate and set up this. You start plotting the chart using the real-time data. So where sometime you can see, by seeing the thing, you can you can understand the processes. Like sometime out of control may happen. So by seeing the trends, you can easily detect those things. Sometime it is a wave type, like it a wave type, it comes and goes up and comes below the average line and then goes up. The best control chart is if it is equal spread, both the sides, above in a upper side and lower side. If it is symmetry, then it is a very good, a process is in control, and within, it should be within these control limits. So if anything, a deviation, one-sided thing, if it is a higher side or lower side, or something unique pattern, if you observe, probably that an indicator for the process out of control. So I said earlier, basically the root cause. Root cause is like very easy visual tool basically to capture the root cause while doing a brainstorming session with the with a team, or with a quality team. When you analyze the problem in design related or production related, these are the some of the tools used very effectively to communicate to the team. And once you start using this becomes much easier to understand, and easier to communicate to other members in the team. Quality circles in production system, generally they use these tools. Quality circles, even dashboards in the production system, they use this type of visual tools. So quickly you can understand. And the root cause, this is the cause, effect is written here, or defect is written here, and root causes is written like this. So cause, maybe if you take any production environment, something like methods, material, environment, people, equipment, broad categories we divide. Under that, their specific cause we can capture, and that can be a holistic way of representing the defect. So like that, for each defect we need to do this root cause analysis. So this is very, very useful information in quality improvements. So run chart is, I said, the run chart is just capturing a real-time information over a period of time. You see the x-axis is the time. Suppose if you are capturing every hourly one data point, if you are capturing, you capture the data about the process. So you plot that over a 12 hours. You just try to see whether that process related information, it may be diameter, it may be anything, and y-axis is shown here. So once you capture that, so that basically it gives you some indicator, like its process is probably it shows that it is upward trend. Maybe you need to correct it. There may be a reason for that. So this gives a quick quick basically a warning, basically, so that you can control the process. So that's all. These are the 7 QC tools. So we will try to cover some other quality tools in the next session. Thank you so much.